In this question, we are told that a customer at a gas station is pumping gasoline into a gas tank. And the rate of flow is given by this function, differentiable function f, where f of t is measured in gallons per second, and time t is measured in seconds since the pumping began. And selected values of f are given in this table. So you can see it at 0 seconds, 60 seconds, and so on. And then the question is using correct units, interpret the meaning of integral from 60 to 135 of this function with respect to time. And so this is actually, this integral represents the total number of gallons of gasoline pumped into the gas tank from time t equals 60 seconds to time t equals 135 seconds. And so the second part of the question is use a Wright-Riemann sum with the three subintervals 60, 90, 90, 120, and 120, 135 to approximate the value of this integral. And so let's draw this here. And we have 60 seconds, we have 90 seconds, we have 120 seconds, and we have 135 seconds. And looking at the table above, the rate of flow of gasoline at 60 seconds is 0.1. At 90 seconds, it's 0.15 gallons per second. At 120 seconds, it's again 0.1. And then at 135 seconds, it's 0.05. And so we need to approximate it using a Wright-Riemann sum. So Wright-Riemann sum actually means that we have to take the value at the right end of those rectangles. So this is what we are approximating it with. So then we just need to find the area of these three rectangles. And so we'll just multiply base times height 3 times. And so this area integral 60 to 135 f of t dt is approximately equal to 90 minus 60. This is base times height 0.15 plus 120 minus 90 times 0.1 plus 135 minus 120 times 0.05. And so we can use our calculator or just calculate in our heads. This is 30 times 0.15 plus 30 times 0.1 plus 15 times 0.05, and this is equal to 4.5 plus 3 plus 0.75, and so this is equal to 8.25. So the total amount of gasoline that was pumped into the gas tank between 60 seconds and 135 seconds is approximately equal to 8.25 gallons. Part B relates to the same question, and the question is, must there exist a value of C between 60 seconds and 120 seconds such that the derivative of this function is equal to 0? And the answer is yes, such a point must exist, because by the mean value theorem for the interval from A to B, there must exist such a point C, which is between A and B, that f prime of c is equal to f of b minus f of a divided by b minus a. And so in our case, b is 120 and a is 60. So let's calculate f prime of c is equal to f of 120 minus f of 60 divided by 120 minus 60. This is equal to, from the table, 0.1 minus 0.1 divided by 60, which is equal to 0. So by the mean value theorem, it has to be the case that such c with the property that the derivative at that point c is equal to 0 must exist. Part C of this question already has nothing to do with the tables that we've seen, and so it only has to do with the rate of flow of gasoline, the same kind of problem. But now we are given already a different function, g of t, and using this model, find the average rate of flow of gasoline over the time interval from 0 to 150 seconds. So this average rate of flow is equal to 1 over 150 minus 0 times the integral from 0 to 150 of g of t dt. So this is equal to 1 over 150 times integral from 0 to 150 t over 500 times cosine of t over 120 squared dt. And so let's pull out our calculators and calculate this value, this integral. And so let's calculate this value. It's 1 divided by 150 times the integral, integral from 0 to 150 of the function x. I'm using x instead of t. X over 500 times cosine of the function parentheses x divided by 120 close parentheses squared close another parenthesis and then dx. And so we did divide by 150, so this should give us the average value. And so the average value is 0.096. 0.096. And so the answer here is 0.096. So in this part of the question, part D, we are given the same function g as in part C. And the question is find the value of g prime at time equals 140 seconds. And so let's just differentiate g of t first, and then plug in the value t equals 140. And so differentiating this function is equal to 1 over 500 times cosine of t over 120 squared plus t over 500 times negative sine of t squared over 120 squared times the derivative of t over 120 squared will be 2 times t over 120 times finally the derivative of t over 120, which is 1 over 120. So overall, simplifying this a little bit gives us 1 over 500 cosine squared cosine of t over 120 squared minus, I'm just bringing negative in front, minus, and then we have t and t squared over 250 times 120 squared. And then here we have sine of t over 120 squared. And so let's plug in t equals 140. We get that g prime of 140 is equal to 1 over 500 cosine of 140 over 120 squared minus 140 squared over 250 times 120 squared times, again, sine. And here we have 140 over 120 squared. So simplifying this a little bit before we use a calculator, let's do 1 over 500 cosine 140 over 120 is 7 over 6, and then squares will give us 7 squared is 49 over 6 squared is 36. Minus, again, 140 over 120 is 7 over 6, so this is 49 times 120 times 36 is going to be 9,000. 9,000 sine from the same argument, 49 over 36. And so we can pull our calculators out, but this is a pretty straightforward calculation. So this is equal to, I did it, and so this is equal to negative 0.004908. And so approximately this is equal to, rounding out, negative 0.005. And so what does this mean? This means that the rate at which gasoline is flowing into the tank is decreasing, because the sign is negative, decreasing at a rate of 0.005 gallon per second, because it's per second, at time t equals 140 seconds. Thank you for reviewing this long problem, and I will see you in the next video.